Thank you. So today I'm talking about what's going on in the world of Lustre development. It's been actually quite an exciting year. We've been working on lots of new features, and in terms of Lustre's adoption and use in the industry, it's doing very well. The HPC world, we're 9 out of the top 10 systems. Also in AI, the usage of Lustre is doing extremely well and growing, by leaps and bounds. I used to joke that the scale of Lustre is limited by the size of somebody's bank account. And, I'm not sure that that's true anymore. But, it's impressive to see with the work that's been done, we can scale up to these extremely large, compute nodes that are basically as large as supercomputers were, a few years ago. Terabytes of RAM, hundreds of cores, hundreds of gigabytes a second of network bandwidth. And the interesting thing is it's pushing us in directions that, we hadn't necessarily anticipated in the past, but there's lots of interesting challenges and, nice things to work on. So this is just a brief, overview of the various parts of Lustre. I won't get into any detail, but the important thing is that we're able to manage the storage, throughout the entire cluster, right? We can handle, persistent storage on the client nodes for caching. Of course, regular OSTs, NVMe OSTs, disk-based, QLC flash, migrating transparently between different tiers of storage. And, in the old days, we thought that users would be, self-enlightened and, work hard to optimize their codes, for the storage to improve their performance. But these days, we really try to do everything, as transparently as possible, because it's, the scientists want to, science, right? And they don't necessarily want to focus on how do we interface best with the underlying storage, so it just has to work out of the box. So 2.17 is open, and we're landing features. Some of the interesting points, hybrid I/O is started in 2.16. There's still some work to be done, potentially getting, clients up through very high performance rates, single client nodes. Dynamic node maps, there's a whole presentation on that. I won't get into it. Essentially taking all the hard work we've done for decades to aggregate, all of this bandwidth and performance into one file system and then splitting it up into small bits again. File level redundancy, Oak Ridge has taken up the torch on implementing erasure coding. And there's already work being done for upcoming 2.18 client-side compression. A new one that's in here, I'll have a slide on it, is fault-tolerant MGS, something that we're starting to work on. And as well, trash can undelete is something that actually turns out to be not very hard to implement. The way that Lustre does deletion is actually very conducive to having a trash can kind of feature. So the fault-tolerant MGS is kind of the first stage development for Lustre metadata redundancy. And I have a slide on that. Metadata write-back cache. The work has been done. It's unfortunately huge and complex. And the people who are working on metadata write-back cache are the same people who are working through on undelete. So we've actually prioritized the undelete to go ahead of write-back cache. And Lustre metadata redundancy, more things can be done, but I think we actually will have an interesting intermediate stage, and I'll talk about that when we get there. So IPv6 is, it's done. There's still a little bit of things to be improved in terms of configuration and things like that, but it's largely finished. Thanks to, Oak Ridge and SUSE, HPE have been working on that. There is actually some interesting, work that we've been speculating on, is whether we can do InfiniBand without IP over IB, right? We only use the IP over IB to address the nodes, right? And with the new large NIDs, I'm not 100% sure that this will be implemented, but it would be possible to configure, the IB GUIDs directly if we can find some way to get those addresses, right? It's a little bit of a, the EFA that Tim was talking about yesterday, to use, the initial connection, right, to establish how do you get this address. But, it's a bit of a chicken and egg. Do we have DNS? But then you have to have some way to contact DNS, right? So anyway, work that has been done already is allowing mounting without having static IP addresses in the configuration logs, so that it simplifies server configuration. So if you're moving targets around to different nodes, you readdress your storage cluster for some reason. These are things that happen not often, but sometimes. And not having the static NIDs in the configuration makes that all a lot easier. And so the start is just to allow clients to optionally mount without NIDs, but at some point in the future we'll actually stop storing the NIDs. We'll keep them around for a while, because that will allow old clients to continue mounting. And just ease of use in terms of mounting the MGS. If anybody's done a large failover configuration, you can, the mount command line has 8 or 16 MGS NIDs listed on it, and it makes DF and mount and everything horrific. And so I want to clean that up a bit, so we can have round robin DNS, spit out a whole list of NIDs, and then we'll just give them an option to display the DNS name in the mount command line, so that it's more pleasant. As well, one of the optimizations that we've found is that network reads from the server, if this file is sparse, it actually is sending all of the data pages over the network. And so when we're reading a sparse file, it's actually not super efficient. And so we've actually been working on a optimization so that at the LNet level and the Lustre level, we actually get a notification back from the server that says, oh, this is a sparse read, and reorganize your RDMA configuration here for that transfer, so that you're only receiving the pages that are populated. And so that can help quite a bit with the network transfer. And Tim was talking about the EFA yesterday. So hybrid I/O, this is a slide from Patrick, and there's a pretty significant improvement. I mean, this is a write graph. Read is somewhat similar, and so with the small I/Os hybrid, you want to do buffered writes, so that you're aggregating multiple pages in the client memory before you send them out over the network. But at around 1 megabyte sized writes, it's actually becomes more efficient to just do a data copy in memory, and if your writes are unaligned, and then send them out via direct I/O versus putting them into the page cache. It turns out the page cache has quite a bit of overhead. And so we're getting speeds in the 20 gigabyte a second range. There's some expectation that with further optimizations we can get, and this is single-threaded performance, if you have large enough writes then you can get up to 50 gigabytes a second with more optimization from a single thread. But of course, that's predicated on having large enough IOs, which not all applications do. So it's not a, solve every problem, but it will definitely solve some problems. And so I think in the 2.17 timeframe, we will enable, currently hybrid IO, you have to enable it manually, but it will likely be enabled by default, once it gets shaken out a bit more. So this is a slide I started putting in, which is covering some of the interesting things, I think, for, administrators, Lustre users, that we, have this steady stream of small little improvements that, make life a bit easier. And I think people don't actually know that, these things are available, right? I mean, a quick show of hands, how many people knew that L-control, L-control get param and set param have tab completion? Okay, so like a tiny handful. But, it's actually been around for, 10 years that you can get param and MDC and double tab, and then it spits you a list of all the parameters that you can get, right? And anyway, so this is the kind of thing, if it's in the presentation, people will see it now, or get it off of the website. Some interesting ones, find has been improved. LFSDF, especially if you have a system, with hundreds of OSTs, you don't want to grep out, what are the MDT ones? For people who are writing, monitoring and things like that, we tell people, not to hard code in the proc fs Lustre whatever path name, because, due to upstream kernel changes, those paths change between releases. But there is a way now, so you can do this list param -- path. It will tell you the path name for that parameter, so that your application or script or whatever can scrape it directly, but you don't hard code in the actual path for the parameter name. And so that can be, avoid making your script break as upgrades come in. Lots of improvements in man pages, subcommands, and actually another nice one, the get param and list param. You can aggregate the output from multiple lines in the get param, so that it will show you a range of MDT star, for instance, as opposed to 40 MDTs or 500 OSTs. It'll just say, oh, all of these are the same output. And actually, if you find some OSTs or MDTs or whatever parameter you're getting OSC, if they're different, it will actually color highlight them. So it'll say, oh, this one is, the RPC size is 4 megabytes, and all of the other ones are 16 megabytes, right? Another nice one, mount.lustre. You can set per client parameters through a config file on the client node. So that if you have, let's say, data transfer nodes and you want to tune those ones differently, you can set this etc lustre, / fsname.conf and load in different parameters on mount, right, which is kind of handy. Named projects, right, so this existed in XFS utils for a long time, but we'll start using the etc projects file so that you can have, name those projects instead of having numbers. There's also a shortcut, so if you do u : and a username, it will assign that ID as the project ID, right? So that, a common case is that people set up projects ID numbers equal to the user ID numbers and use the project quota instead of user quota, so that you have two different parts of your file system. You can have two different quotas, let's say for home a Dilger versus scratch a Dilger, right? And so they have different even though it's one file system, they may have different cleanup policies depending on what part of the file system you're in, and different backup policies. And so you can set different quotas for the different parts of the file system. In terms of other functionality improvements, we have ongoing updates on the kernels. We're keeping pretty close up to date with the latest kernels. a config one for GPU nodes and things like that. You can say, instead of having to specify a CPT, which a huge list of which cores to include, you can actually just say which cores to exclude, which is a nice simplification. For various cloud usage, you can obfuscate the file names and directory names in the debug logs so that you're not releasing identifiable information. What else? Actually, yeah. So one of the proposals to work on has been the aggregating quotas, so that you can essentially have a bit of hierarchical quota management. So we'd have, let's say, project ID 10,000, controls, as a superset of, the range 10,001 to 11,000 or whatever. And so you can have nested project quotas. Let's see. Yeah, and upstreaming the Linux client. On the server side, obviously lots of work being done. Pool spilling is a neat feature that has been around. I don't know that people are aware of. If you have multiple storage tiers, flash and disk, you can set a tunable so that if the flash tier becomes too full, it will actually redirect straight to your disk tier, so that you don't run out of space when you're writing new files. Amazon wants to work on hidden files. They call super hidden files. They're essentially, they don't appear in ls or ls-a, so that you can put in administrative sort of databases or configuration files into a file system that users can't access or find. And work on the NRS is being done, so you can create rules by node map name or rules by project ID, and use that to filter out, or tune RPCs. And also you can specify ranges of IDs. So you say, oh, this whole range of users gets this performance, and this whole range of, users or projects or whatever get a different performance. And so my hope is that we can get a default quota or default NRS that, kind of keeps, abusive jobs in check out of the box, right? Like currently the default is FIFO. And so if you have the most nodes, you get the most bandwidth, the most RPCs, because you can submit the most. But often, that's it's good for the big job, it's bad for the small job. And we would like to have some sort of balance so that, people are doing LS can get their, LS finished quickly, and that job that's grinding away at the file system, is still going to be grinding 10 seconds later, but you don't want to be the user waiting behind it. In terms of other improvements in terms of performance, more improvements on the rename front, reducing the lock hold time, did some work on optimizing memory usage to squeeze in more locks per kilobyte, and reduce the stats, job stats overhead in terms of walking, because people end up creating tens of thousands of different job IDs now, because it's a handy way to track usage statistics, but they create tons of different job IDs, so improving that is useful. FLock, there was work done to improve FLock performance, so if you have hundreds of thousands of locks on a single file, then you need to manage that better. What else? So read and open on a directory will return the directory contents directly into the first RPC if the directory is small. So it saves you a little bit of latency there. And Tim was already talking about the RAM-based OSD, which I think not only is good for testing, I think that actually it will be useful in the future. There are some sites doing essentially this with TempFS or RAM disk. And so if we can have a RAM-based OSD, I think it will actually be useful for some kinds of large very temporary workloads. And the write-back caching, this goes hand in hand with the hybrid I/O, so that you can submit small and unaligned IOs directly to the server side and aggregate them before they go to disk. Right now, on the LDiskFS front, at least, the IOs are right through, and so we never have it. We may cache the writes, but still only after it's written to storage, and so this will allow aggregating and optimizing the I/O. On the LDiskFS front, we have patches to do persistent trim support, and so that's essentially the current implementation only has an in-memory flag to say whether groups have been trimmed, right? And so if you run trimming repeatedly, it keeps the state in memory, but if you unmount and remount, it loses all of that state. So if you've just, erased your whole device and then you format it and then you mount it, then the next trim is going to re-trim the whole thing. And so that's inefficient. And also, there's not a good live trimming mechanism, right? You can run, FS trim over and over again, but, how quickly do you do it? Does it have an impact on existing performance? And so there's a way to combine the persistent trim flags with the new MB allocator, so that we can do essentially in-memory trimming with only on groups that have recently had a lot of blocks deleted, right? So we can follow with the allocator, oh, this block or this block group just had 10,000 blocks deleted, so we'll do a trim on that right away. And so then you can just keep, instead of having like spikes of FS trim workload, you can have trims being submitted periodically through the usage. Hybrid LVM is a new kind of feature that allows you to have both NVMe and HDD OSTs like in one OST, and it's using LVM underneath to concatenate a flash region that will store all of the inodes, and that's I think useful for certain workloads with very large OSTs. On the multi-tenancy front, I'm not going to talk too much about this one because Sebastian has a whole talk on it. And erasure coding, it's a very nice feature that has been pending for quite a while. I don't know where James is, but I'm hoping that he's going to be providing some improvements on the erasure coding front. The initial implementation will be essentially read-only erasure coding, but that will be still useful for workloads where you have read-mostly data and you want to have some redundancy so that it can withstand an OST failure, and you don't have to wait for failover and fail back and things like that. You can still continue reading your files. So I think even the intermediate stages will be interesting to use. Client-side data compression. There's actually a presentation later today on this, so I won't get into too much detail, but it does what it sounds like. It compresses data on the client, and in a way that you can still do random I/O into the file without having to recompress. It's not a whole file compression; it's a chunk-wise compression. This is actually a newish feature, the trash can undelete. It's something we started looking at. I mean, the way that Lustre works with deletion today is that we already delete the file name into a folder, and then the object deletion happens in a second stage in order to keep, we don't leak space if you crash the MDS right in the middle of a delete. And so actually putting the files, instead of just this holding directory, if we put it into a trash can, per user, then you can actually recover the files, for some time after, after they've been deleted. And so we would have a very simple policy, which is delete the files, after some amount of time that they've been in the trash, or if the file system gets, over 80% full, something like that. And having a more sophisticated policy could be done in user space. But when the files, get deleted, they'll be put into these internal holding directories, but we will make those holding directories visible as a virtual .trash directory in each subdirectory of the file system. So that you can do, if you do rm, foo, you can do, lfs unrm foo immediately, and then it will pull it back out of the trash. So I think that that's actually a pretty useful thing for users. They can, do that recovery themselves without, needing to involve a backup, restore, administrator, anything like that. The other area that is seeing some action finally is on the metadata redundancy side. So there's a whole, this lists a whole series of steps to get full redundancy, but we're starting, at the top, fault-tolerant MGS. That's something that is, it's pretty straightforward to implement. The goal is to make, all of the MDT zero services, independent. And so we're going to be, we're looking at using Raft to do configuration replication between nodes. And so essentially every MDS will have an MGS service running on it. And so when clients connect, to any of the MGS NIDs, they will all be responsive and be able to provide clients with the configuration. And Raft is fairly simple, and we actually have an implementation that can be built in the kernel fairly easily. And since the MGS doesn't change very, the logs don't change very frequently, we have it's not a very high overhead to replicate it to all of the different systems, but it's nice to have a copy and just make it reliable and updated consistently. And then, so this will lead on to the next phase of the metadata redundancy, which is being able to remove MDT0 from the file system. So it's not going to be full, metadata, you get a mirrored MDT or anything like that. It's only going to allow mirroring of the root directory, which we, currently require, be on MDT0, and the other services that live on MDT0, such as the FID location database, quota manager, the FLock locking manager, and along with the root directory, then you can be able to remove MDT0 from the file system and do hardware replacement or things like that. We've been able to migrate, OSTs around, but right now MDT0 is a must-have, and so it would be, convenient for configuration purposes to be able to replace that. Metadata write-back cache, I've talked about this in the past, so I'm not going to talk too much about it. There's a lot of code there. What we really need to do is, have a thorough review of the code and make sure that it's implemented in the best way. And it's unfortunately quite complex, and so it's easier to do 5 small projects than 1 big project. And it has some very significant. I mean, there's the graph shows here in the testing that we got about 100 times performance improvement for very specific, single directory workloads like untar and make and things like that. So it's a nice improvement, but it's hard work getting this landed into a release. And so it hasn't come about, but the lure of these performance gains, make it attractive to keep looking at. The other thing that people always ask about, is POSIX going away, right? And I think that's not happening. I think everything, rather than POSIX going away, I think that everything, ends up providing a POSIX-like interface. I mean, you know, Lustre is providing almost everything of POSIX. We actually fixed a POSIX-related bug, you know, in the last month, right, which was quite surprising. You know, or been around forever, and somebody has a little weird workload that did, you know, it was like, I can't remember, changing the group on a file that you don't have write permission to or something like that. And anyways, you know, there's a million little corners of POSIX. I think we handle almost everything. On the flip side, having other APIs than POSIX is important, and so I think there should be, you know, shortcut or optimized interfaces. IOU ring is one of them. You know, there's been discussions, you know, lately, should we have an optimized KV interface, you know, into the Lustre storage, because we do have a KV, you know, structures inside our code because we need, you know, directory handling and things like that. You know, we can scale to billions of you know, keys in a single, you know, directory. And so should we expose something like that, you know, up to user space? And what would be the best interface to use? Is there, you know, I don't think there's any kind of standard interface, but, you know, what would be the best way to expose this up? There is, you know, IOU ring, both, you know, originally it was for data, but you can actually start doing IOU ring metadata operations, which is nice, and I think we just get that for free. You know, so I think that there's definitely room for exposing things, even like, you know, exporting S3 operations, having a file join, right? I think there's actually somebody at HPE working on you know, implementing file join so that you can do multi-part uploads and then join those files into one big, you know, file object for the S3 storage. And so I definitely think there's room for improved interfaces, but I don't think that we should weaken POSIX. I think it should be all opt-in, that applications that want something different should get it, but we shouldn't break, you know, the expectations of applications, you know, because it's hard to know what subset of POSIX applications depend on, right? So anyways, that's, I think I've gone through my slides already. Questions?
Questions from the audience? Yes, when you were talking about the changes from using IP over IB, using like the JID, how would that work if you're using like a bonded interface for failover? Or would that be a change where you'd then just multi-home them? Yeah, so I mean, the interesting thing is that could combine well with the next line, actually, the mount without NIDs. So essentially, in the mount without NIDs, we already have a mechanism called imperative recovery, where the servers advertise their list of NIDs up to the MGS after mount, so that when the clients are, you know, doing failover, they don't just randomly poke at all of the different failover NIDs. They actually get this list of NIDs directly from the MGS. And so at that point, the servers could advertise their, you know, GUID NIDs directly to the clients, right? And so with that feature, the clients actually, they mount and they say, okay, here are these OSTs, I don't know where they are. They get the imperative recovery list from the MGS, and so there isn't anywhere to store all of those addresses. They just get populated from the servers directly, right? And so we don't really have to store it or look it up or anything like that. They advertise it. It's just, you know, do we only have a TCP connection to the MGS? And then you're wondering, it's like, once you have one TCP connection, you know, it ruins the whole game, right? So, you know, like I said, a little bit of a chicken and egg problem there.
Do we have any additional questions right now? Andreas, you realize that according to my schedule, you had like an hour.
Yeah, I know. I mean, normally I compress this into a shorter time, and so I've maybe rushed through it. I don't know if there was actually lots of things that I glossed over. I mean, I don't know if people have other things that were interesting to talk about.
So I know there's a lot of other storage systems out there that tout that they have POSIX API and then some kind of like native object API. Do you think Lustre will ever grow some kind of native object API?
It's a good question. I mean, we could start offering, some sort of S3 API directly. I mean, Lustre has objects underneath, right? We've just never exposed it because, for many years, the object part wasn't the interesting thing, right? And so today we do allow, like you can do min.io exporting, from the object. I think the right thing to do would be to have, min.io, have an optimized path where they can just get, access to these objects without going through, locking and POSIX read-write ordering, because the I/O model for S3 is very, poor in a sense of it's feature poor. You can do very specific things, write, append only. They're, they can't get overwritten after they're created and things like that. So we can simplify a lot of things, whether somebody wanted to put in the whole S3 stack, into the kernel so that OSTs could export it, directly via, TCP sockets. It's not something that I personally would want to do. I think it would be possible. I think that we could also, optimize the I/O path and put in special hooks, like I said, with the file join, right? So that you can do multi-part uploads. You join those things together without doing a read, copy, write, to get a single object at the end. So I think there's room to optimize that. Whether Lustre will do that itself, I don't know, does it need to, right? There's, NFS re-exporting, there's SMB re-exporting, and if we make those things fast enough, we don't have to glom everything in. It's the same with, the decision not to implement our own disk file system, right? We, some Ceph or whatever, they implemented, BlueStore to give themselves their own persistent file system, but actually we've benefited in the, in the early ext4 days, we did a lot of the ext4 development, mballoc and extended attributes, large hash directories. But actually on the flip side, now we're getting a lot of, improvements, fscrypt and other things coming into the ext4 world. So if we have everything on our own, it means we have to manage it all on our own too. And so taking something like min.io and replacing the bottom end to interface with Lustre at an optimized way, I think would be a better solution. So.
Would you run into licensing issues with min.io since they're GPL v3?
No, it doesn't necessarily have to be in the kernel, right? We would provide an interface to user space that they could, bypass all of the DLM locking or something like that. So it wouldn't be like an aggregated single unit. It would just still be min.io running in user space, but calling new, like non-POSIX APIs to get better performance, right?
This is a great set of new features that Lustre is working towards. Is there a design review process, design documents, or is it just a person over email having the conversations with a subset of people?
I think it depends on the specific, project and what's being worked on. I mean, on the one hand, Lustre is open source, and so we can't, enforce what people are doing for their contributions. And, in the end, the important thing is what they contribute and not the process they went through to get there. But definitely for, some of the like say trash can, there's a design document, you know, that we're going through and we're talking about. I mean, the interesting thing actually with TrashCan is that the functionality is basically free. It's already all been done and implemented. The hard part is getting the semantics right for the user interface, and how do you make, you know, delete and undelete, how does it integrate with other features in the file system, like quotas. If you delete your files, but your quota doesn't go down, you know, that doesn't help a user either, right? And so, you know, we have to shift the quota usage over to like a trash quota account, and then how do they, you know, retrieve their files? You know, the .trash virtual directory, you know, is making the user interface easier, and so a lot of it is, you know, all about the usage experience. So we do have a design document. We're talking about all of these things with the metadata redundancy, again, fault-tolerant MGS. You know, we have a design document we're going through, and what are the semantics and how does it integrate with Raft? You know, because Raft has its own, you know, ideas about how to log and how to communicate and all of these things. And we're, you know, in the existing, you know, Raft code that we're going to use, you know, we'll be replacing all of the network communication with LNet, you know, Lustre RPCs, and the log file will be, you know, the Lustre log and things like that. So it's, you know, there's a lot of discussion up front in complex projects. Some of them just grow organically, and, you know, it, like all of these, where is it? These, you know, user tool improvements, you know, there's a ticket opened, and a lot of them, you know, as people, you know, complain about something in the mailing list or whatever, we create a ticket and it describes, oh, you know, it would be nice if we had this feature, and there's a couple of paragraphs, and then, you know, some new person comes in, these all get marked in Jira with an easy flag, and then, you know, somebody comes in and works on it. I mean, in fact, many of these ones were, my sons were working as interns last summer, and so they picked up these things. But they're also, you know, for hackathon and things like that, like the XAdder related ones. One of the features that got implemented at a hackathon a couple years ago was storing the job ID in files as they're getting created. So actually you can do a little bit of you know, spelunking into the history of a file by seeing, oh, it was this application or this job that created these files, and you can have the bit of the provenance. And now with the find-xadder, you can say, oh, you know, find all of the files that were created by this job. Right, and you know, one of the corollaries of that was storing the job that deleted a file, you know, into the file as it's getting deleted. And, you know, it wasn't very useful idea, because you know, the file is deleted and you'd have to use debugfs and things like that to poke at the on-disk inode. But with the trash can, now having the name of the process that, you know, and the user ID and everything like that, that deleted the file, then you can say, oh, this was my rogue, you know, rm-r job, you know, or this script or whatever it was that was doing this deletion. So those things come up, you know, just with a little bit of discussion in a Jira ticket or email or something like that.
Okay, thank you.
I have a question actually related to Mount Lustre, you know, the improvement there.
Yeah.
Will it be possible with this to apply like set params? That's the idea.
Yeah, it's exactly
so
that.
All the tunings can be applied at runtime from a file in etc Lustre. Right?
Yeah, well, it's actually a file inside etc Lustre. That's a directory. It wasn't, I guess, very clear.
Yeah.
But so you can have, there's an etc Lustre / I don't know, it's like mount.params or something like that, and then there's a mount.fsname.params, and so then the generic one gets applied first, and then the .fsname one gets applied afterwards, so you can have both, you know, things that are to a bunch of clients, and then if you have multiple different file system mounts, you can get different ones applied. And so it's just a list of set param commands, essentially. And then you can apply those. There's some discussion about allowing on the MGS to have like per node map parameters, so that when you mount with a node map, the client will also get a new set of parameters, but that wasn't implemented. This was actually super easy to do, and again, was one of those easy, you know, little projects to improve, but people have been asking about client-specific mounting for, you know, mount options for a long time, and this was a relatively straightforward way to get that.
Yeah, I think that's going to be very useful. I mean, we often mount Lustre on clusters via a wrapper that applies tuning.
Yeah, no, and that's the thing, like, you can't do it via static anything. It has to be at the time of mount, right? Because if it's an RC whatever scripts, you know, then it's you know, too early or too late, right?
Other questions? Oh, yes.
My question is about the permanent parameter that you can set on the MGS.
Okay.
The only way I have to actually view these parameters is actually go across the cluster, client, or MDT and OST to actually see these values if they were set. But I don't have any way through lcuddle, get param, to actually get these parameters.
Yeah, there's actually a command. It's lcontrol llog_print, and then the config name. So if you do llog, well, there's actually lcontrol llog, I think there's list, will show you the list of all, it's running on the MGS. It will list all of the config files. You can do, you know, lcontrol llog_print params, right? And that will print all of the params that were set. And then you can actually, you know, you can delete them out if you want. There's actually a whole bunch of commands. It's just, unfortunately, those things are not get param and set param or list param. So maybe we should add in an alias, right? That'd be if you file a ticket.
That would be nice,
you know.
I'll file a ticket.
Yeah.
I guess, apologies, because I haven't read the design doc yet, but do you know if the e-trash can is going to have an disable or not use it?
Oh, yeah, for sure. I mean, it's, you know, we always, any new feature, you have an option to enable and disable it. And so, you know, for this feature, the expectation is that it would be on by default because, you know, we had an unfortunate incident where Lustre deletes files really fast, and you know, somebody deleted a large part of their file system, and you know, it doesn't help them if that feature existed, but they didn't have it enabled, right? And so the good thing is that the way that it's structured is that if you, let's say you did an rm-r f star, right? It's not going to put a billion files in the trash, right? It's actually, when it deletes files, it creates a stub directory for the current directory, and then anything that's get deleted from this directory goes into the stub, and it populates that, and then when that directory actually gets deleted, the stub gets the name of the deleted directory and gets pushed down a level, right? So even though rm-r is deleting from the bottom up, we're essentially pushing it down a stack, and so at the end of the rm-r, you'd actually be left with a set of the top level directories. Let's say it was home, you know, you'd have a .trash, a Dilger, and a .trash, you know, J Smith or whatever, and then you can do unrm and actually get the whole tree back in one step, right? And so it's, you know, it's definitely, we're looking at the usability side. I mean, turning it on and off for sure. There's also going to be a parameter you can set on files to disable files from going into the trash if you want to do, you know, files that you know are just temporary scratch and you don't want to keep, you know, thrash your trash can, you know, they would just be deleted directly. But, you know, there's always, any feature we do has an on-off switch because you never know if it's, what people want or causes some problem in the field, unexpected use case or whatever. So that's always the case.
Awesome. Thank you.
There's a special command to get the config parameters you set in a YAML format. It's an obscure command that most people don't even know exists. So it is possible to do that.
James was partying pretty hard last night. So to repeat what James was whispering, there's a command to dump all of the configuration in a YAML format, and that's the LUG print will dumps it, all of the commands in. And there's no, I think that, well, the LUG print. There's also an option to take the saved, like if you dump all of the tunable parameters, there's I think it's set param dash YAML or dash file or something like that that lets you reapply all of those parameters again in a batch, so that you can save and restore those if you want.
More questions?
Any more questions?
All right. We're done early.
Thank you.
All right, thank you.
Thank you very much.